everyone. I am here today to discuss to you about algebraic expressions and polynomials. Now let us have first definition of terms. So first, we have to discuss or give the definition of algebraic expression. So algebraic expression consists of one or more terms. Let us have example. We are given here 3x squared minus x plus 5. In 3x squared minus x plus 5, we have 3x squared, negative x, and 5 are called terms. So what do we mean by term? So term, it is a constant, a variable, or a product of a constant and variable. So it means that a term can be a constant, just like this 5. So 5 is a constant and it is a term. It can be a variable, just like negative x. So it is a variable, x, negative x. Or a product of a constant and variable. So example, we have 3x squared. So we have a constant here and the variable with the exponent. So it is a product of a constant and variable. Now, in the term 3x squared, 3 is called the numerical coefficient and x squared is called the literal coefficient. Now, in the term negative x, negative 1 is the numerical coefficient. So, why is it negative 1? In our term negative x, it means that there is 1 here before the variable x. So, 1 cannot be seen, but it means that there is 1 as constant before x. So that's why the numerical coefficient is negative 1. So there is negative 1 here before x. And x is the literal coefficient. Now the term 5 is called the constant, which is usually referred to as the term without a variable. Numerical coefficient is the constant or number, while literal coefficient is the variable including its exponent. So the word coefficient alone is referred to as the numerical coefficient. Take note of that. So we have here also the term degree. So what do we mean by degree? So degree is the highest exponent or the highest sum of the exponents of the variables in a term. So let's have example. In 3x squared minus x plus 5, the degree of this is 2. So why is it 2? Because the highest exponent in our variable x is 2. So we have here x, the exponent is 2. We also have x here. So when there's no number as exponent, it means that the exponent is 1. While for our constant, it means that the constant alone, so there's no variable. It means that the degree is 0. So the highest degree is 2. So therefore, the degree of this algebraic expression 3x squared minus x plus 5 is 2. Now let's have another example. So in 3x squared y cubed minus x to the fourth y cubed plus 2, the degree is 7. So why is it 7? Because if the term consists of more than one term, just like this, so we have more than one variable rather. So just like this one, we have x and y. We also have x and y here. So we will get the highest sum of the exponents. So in our first term, we have 2 and 3. So 2 plus 3, we only have 5 in this term. Now for the second one, we have 4 and 3. So 4 plus 3, 7. So while in this is 0. So we have 5 and this is 7 and this is 0. So the highest sum of the exponents of the variables is 7. So therefore, the degree of 3x squared y cubed minus x to the fourth y cubed plus 2 is 7. Now, we also have these similar terms. So, what do we mean by similar terms? So, similar terms are terms having the same literal coefficient. So, again, when we say literal coefficients, it is the variable including its exponent. So, we have similar terms are terms having the same literal coefficients. Okay, for example, we have here 3x squared and negative 5x squared. So they are similar terms. Why is it they are similar? Because they have same literal coefficient. So this one, the literal coefficient is x squared. And this one, we also have the literal coefficient as x squared. So they are similar terms. Now let us have another example of similar terms. So we have here, okay, or different terms, opposite of similar terms. We have 3x squared y cubed and negative 5x squared y squared. So if you notice, we have this literal coefficient x squared y cubed. On the other hand, we have x squared y squared. So we don't have similar literal coefficient. So therefore, these two terms here are the similar terms. Okay? So they are the similar terms. When we say similar terms again, these are terms having the same literal coefficients. Now, another example, let's say we have 7x cubed y to the fourth and negative 15x cubed y to the fourth. So they are similar terms. So why they are similar? Because we have here the literal coefficient x cubed y to the fourth. And for this one, the literal coefficient is also x cubed y to the fourth. So that's why 7x cubed y to the fourth and negative 15x cubed y to the fourth are similar terms. Now, let us have another example. We have here 2x squared and negative 9x. So, they are dissimilar terms because they have different literal coefficient. For the first one, we have x squared as literal coefficient. And for the second one, we have x as literal coefficient. So, they do not have the same literal coefficient. So, therefore, these two terms are dissimilar. So, what is a polynomial? So, a polynomial is a kind of algebraic expression where each term is a constant, a variable, or a product of a constant and variable in which the variable has a whole number exponent. Meaning, an algebraic expression is not a polynomial if, number one, the exponent of the variable is not a whole number. So take note, we are only talking about the exponent of the variable. We are not talking about the numerical coefficient or the constant. So we will focus on the variable. So the exponent of the variable is not a whole number. So if it is not a whole number, therefore, the algebraic expression is not a polynomial. Now for the second one, the variable is inside the radical sign. So when you see a variable written inside the radical sign, whether it is square root, cube root, fourth root, or nth root, so therefore we cannot consider this algebraic expression a polynomial. Okay, third, the variable is in the denominator. So when you see a variable written in the denominator, this algebraic expression is not a polynomial. So tell whether the given expression is a polynomial or not. And if it is a polynomial, determine its degree. Okay, let's have number 1. So we are given 6x squared. Is it a polynomial or not? So it is a polynomial because the exponent of the variable is a whole number. So therefore, this is a polynomial. And if it is a polynomial, the degree of 6x squared is 2 because it consists only of one term. Automatic, the degree of the variable in a term is the degree of the polynomial, so which is 2. Now let us have the second one. So we are given negative 2x cubed plus 5xy. So can we consider this algebraic expression a polynomial? So it is a polynomial because the exponent of the variables are whole numbers. So we have 3. Here we have 1 for x and we also have 1 for y. So therefore, this is a polynomial. And the degree of this polynomial is 3 because in our first term, the exponent of the variable is 3. And our second term, the exponent of the variables are 1 and 1. So when we add it, it is only equal to 2. So the highest exponent is 3. So therefore, the degree of negative 2x cubed plus 5xy is 3. Now let us have the third one. X raised to 1/2 minus 4x plus 7. Is this given algebraic expression a polynomial or not? So this is not a polynomial. So why is it not a polynomial? Because the exponent of the variable is in fraction. It can be polynomial if and only if the exponent of the variable is a whole number. But since we have here an exponent which is a fraction, so therefore this is not a polynomial. Okay, let's have number 4. We are given here 12. So this is a constant term. So if it is a constant term, of course, it is a polynomial. And if it is a constant, the degree of this polynomial is 0 because we don't have any variable in this term. So we only have constant. So if it is a constant or a number, the degree is 0. Now let us have example number 5. We are given here 3x squared times the square root of 5x minus 1. So it is a polynomial or not? So this is not a polynomial. So why is it not polynomial? Because there is a variable written inside the radical sign. So if there is a variable inside the radical sign, an algebraic expression, this is an algebraic expression but not a polynomial. Now let us have example number 6. We are given here 2x cubed plus 5xy minus x to the 4th. Since the exponents of each variable in the given terms are whole number, so therefore this is a polynomial. And if it is a polynomial, the degree of this polynomial is 4 because the highest exponent or the highest sum of the exponent of the variable or variables is 4. So for the first term, we only have 3. For the second term, we only have 2. And for the last term, we have 4. So the degree is 4. Now let us have example number 7. We are given here x raised to negative 7 minus 4x plus 9. So can we consider this algebraic expression a polynomial or not? So this is not a polynomial since the exponent of the variable x is a negative number or negative integer. So therefore, this is not a polynomial. Now let us have example number 8. So we are given here 6 over y cubed minus y squared plus 10. So can we consider this algebraic expression a polynomial or not? So this is not a polynomial because we have a variable written in the denominator. So if it is written in the denominator, it is not a polynomial. If the variable is written in the denominator, it is not a polynomial. Okay, let us discuss different kinds of polynomial. So we have different kinds of polynomial according to the number of terms. So first, we called it as monomial if the polynomial consists of only one term. So we called it binomial if it is a polynomial with two terms. Okay, third one, it is called trinomial if the polynomial consists of three terms. And last, we called it multinomial is a polynomial with four or more terms. We called it as multinomial. Now, we also have kinds of polynomial according to its degree. So, the first one, if it is a constant, a polynomial of degree 0. So, we called it a polynomial of degree 0. Number 2, we called it constant. Number 1, constant if the polynomial has a degree of 0. Number 2, we called it linear polynomial if a polynomial is in degree 1. Number 3, quadratic, a polynomial of degree 2. Cubic, if it is a polynomial of degree 3. Quartic, we called it as quartic polynomial if it is a polynomial of degree 4. And we have quintic if it is a polynomial of degree 5. Okay? So the next degrees have no universal name yet. So they are just called polynomial of degree. It depends upon the degree. So let's say we have 6. The degree is 6. So we called it as polynomial of degree 6. Or if the polynomial has a degree of 7, so we called it as polynomial of degree 7. Now, a polynomial is in a standard form if its terms are arranged from the term with the highest degree up to the term with the lowest degree. Now, if the polynomial is in a standard form, the first term is called the leading term. The numerical coefficient of the leading term is called the leading coefficient. Okay, we are given here example for rewriting the given polynomial in standard form. So we are given 2x squared minus 5x raised to 5 minus 2x cubed plus 3x minus 10. So it will be written in its standard form in negative 5x to the 5th minus 2x cubed plus 2x squared plus 3x minus 10. So take note that if we are going to rewrite it in standard form, we must rewrite the term with the highest degree up to the lowest degree. And take note, when we rearrange the term, the sign before the term is included. So for example here, minus 5x raised to 5. So minus here means negative. So if we are going to rewrite it, so in the first term, it will be negative 5x raised to 5. And also with minus 2x cubed. So it will be negative 2x cubed or minus 2x cubed. Then we have positive 2x squared. Then we have positive 3x. And then we have negative 10 or minus 10. Now, after rewriting it in its standard form, so we can now get the leading term. So the term negative 5x raised to 5 is the leading term. Negative 5 is its leading coefficient and 5 is its degree. Since 5 is its degree, so we called it as quintic polynomial because its degree is 5. So now let us have examples. So we complete the table. We are given the polynomials and then we have to rewrite it in its standard form, then get the leading term, the leading coefficient, determine the degree, then the kind according to the number of terms, and the kind according to the degree. So for example, in number 1, we are given here 3x plus 7. So since it is already arranged from highest degree to the lowest degree, so we have 1, 0, so it's already in its standard form, 3x plus 7. Then the leading term, so the first term after we arrange it in its standard form, so leading term is 3x, and then the leading coefficient is 3. So when we say leading coefficient, it is the numerical coefficient of the leading term. So the degree is 1. And the kind of polynomial according to the number of terms, since it consists of 2 terms, we have 3x and 7, so it is a binomial. And since the degree is 1, so we called it as linear polynomial. Now, let us have second example. We are given here 3 minus 4x plus 7x squared. So, we have to rearrange it from the highest degree to the lowest. So, we have 7x squared minus 4x plus 3. So, take note that we include the sign. So, the leading term, after we arrange it in standard form, so we have 7x squared. And then the leading coefficient is 7. And the degree of the leading term is 2. So, therefore, the degree is 2. And the kind of the polynomial, according to the number of terms, is trinomial because we have 3 terms. So, 7x squared, negative 4x, and positive 3. So, we have 3 terms, so it is trinomial. And since the degree is 2, so we called it as quadratic polynomial. Quadratic. Now, for number 3, we are given here 15. So, in its standard form, it's already 15 because we consist only of 1 term. Then, the leading term is 15. The leading coefficient is 15. Since we don't have a variable, so the degree is 0. And the kind of polynomial, according to the number of terms, it is monomial because it consists of 1 term. And since it is a constant, so we called it as constant polynomial. Now, for number 4, we are given here x to the 4th minus 5x cubed plus 2x minus x squared minus 1. So, we have to arrange the given term to the highest degree up to the lowest degree. So, we have here x to the 4th minus 5x cubed minus x squared plus 2x minus 1. So, take note of the sign together with the sign. Okay? So, therefore, the leading term is x to the 4th. The leading coefficient is 1. So, sabi ko nga, if there's no number in the given variable with the exponent, of course, the numerical coefficient is 1. So, therefore, the leading coefficient is 1. And the degree is 4. So, the kinds of polynomial according to the number of terms, we have here how many terms? We have x to the 4th, 1, negative 5x cubed, 2, negative x squared, 3, positive 2x, 4, negative 1, 5. So, it is 5. Consists of 5 terms. So, therefore, it is a multinomial. And since the degree is 4, so we called it as quartic polynomial. Now, let us have the last example. We are given here 8x cubed. So, in standard form, we have 8x cubed. The leading term, 8x cubed. The leading coefficient is 8. And the degree is 3. So, the exponent is 3. And it is consists of only 1 term, so we called it as monomial. And since the degree is 3, so we called it as cubic polynomial. Okay, that's all for today. Thank you for watching. Stay safe and God bless.